the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
Is the best option. Okay, shifting our environment to net zero. Right now, what we're looking at is a very dirty, high impact built environment. And what we want to do is shift it over to green. So we're getting even a net positive regeneration happening within the next couple of generations. So I thought that this image would be a good one to start with, because that's what I really envision in my mind. We're not tearing everything down. We don't have the energy to do that, and it would be a waste to tear everything down. So how do we green everything up? You know about me, just a little bit about my consulting practice, Affecting Change. I established it in January of 2010 just to help along that transition to net zero. And we don't think of ourselves as the organization that does the change. It's really our clients that are doing that change. So we think of ourselves as the mountain. We have our logo is the mountain, and we look at how we can stand for what's possible and how the water and the change can run over and through. And we redirect that change, and we help our clients with that transformation. Just a little bit of a land acknowledgement. We're based in Toronto, so the sacred land that which we operate has been the site of human activity for over 15,000 years. This land is the territory of the Anishinaabe, the Haudenosaunee, the Wendat, and most recently, the Mississaugas of the Credit. The territory is subject to many wampum-built agreements between many nations to peaceably share and care for the resources around the Great Lakes. Ontario is covered by 46 treaties and other agreements. Today, the meeting place of Takaranto is home to the Indigenous people from across Turtle Island. We are all treaty peoples, and our intersecting communities are comprised of those that are native to this land, Indigenous people from other territories, as well as settlers who have come here by choice, force, or otherwise as a result of colonialism and imperialism. We're grateful for the opportunity to work on this land and with its original caretakers. We work across the globe. So our organization works on projects on multiple continents. We're working on projects in Canada, from Newfoundland all the way over to British Columbia on the West Coast. So here's our agenda for our talk today. What role do our buildings play in our cities? Why is climate action such an urgent issue, and why must action be taken without delay? How do you move a portfolio of buildings to net zero? Is LEED the best rating system? And I want to start with what role our buildings play in our city. And that really looks at the impact of our built environment on our ecosystems, on our energy systems, and on our climate. We'll go through each one. How do they impact our ecosystems? Well, this is a little snapshot on the left of what our ecosystems looked like in most of southwestern Ontario before the colonials arrived. So the Indigenous communities actually worked with that land. It's not virgin land as you would think. It actually is a land that worked in synergy with the Indigenous communities. So what the Indigenous people found was that certain plants actually didn't do so well without them harvesting them. There's a great book if you want to look into more about Indigenous culture and how people live in harmony with the environment. A great book is called Braiding Sweetgrass by Robin Wall Kimmerer. On the left, what you see is a savanna ecosystem that is still retained in High Park, just to the west of the city. And it's only about 15 minutes by subway from this location on the right down at Front and Bay Street in Toronto. So what the buildings are doing is that they are covering the land. So they make the stormwater act very differently on the built environment than on that savanna on the left. The built environment is less permeable to the stormwater, whereas the savanna is very permeable. It was very attractive for colonials to settle here on the savanna grasses because they're quite open. It was easy for them to build in those areas, and it was easy for them to clear that land and make it into the farmland that it is today. Our built environment also is heated and cooled primarily using fossil fuels. So the fossil fuels spew into the sky. You can see them on really cold days, even on really warm days. You can hear the air conditioning is running. If we were to shut down all the electricity grid and turn off the natural gas systems, then our buildings would be uninhabitable within hours. And I'll show you some buildings that are high performance that are actually inhabitable without using fossil fuels. So how do buildings impact our energy systems? In Toronto, we can break down our energy usage into 3 different categories. 19% is used for industry or manufacturing facilities and assembly plants. In Toronto, 44% of our energy is used for buildings, the heating and cooling energy that I was mentioning. And 34% is used for transportation. Now the building and the transportation work together, because if you have cities that aren't planned well, then people are going to have to use their cars more. And then your transportation emissions are going to go up. If you have cities that aren't planned well, then you're not going to get as enough passive solar energy into those buildings, and they aren't going to be heated enough. So you're going to have to use fossil fuels to heat them. So they're very intrinsically linked together. On the following slides, what you'll see are footnotes and links. All the links are going to be hot links if you download the PDF lecture slides that are available from your professor. So feel free to dive into those links and check out more information about all of these topics. If we look on a global scale, the urban built environment is actually responsible for 75% of the annual global greenhouse gas emissions. And that's the built environment itself. Buildings alone account for 39% of the emissions globally. So that's a huge built building footprint, but it's also a huge opportunity. Why is climate change such an urgent issue, and why must action be taken without delay? The impact of global warming is dire. There are huge risks with the continuation of global warming. So on the right-hand side, you can see a explanation of what this graph means, but I'm going to just spend a little bit of time explaining this. This is from the IPCC's latest report on climate change and the impacts of climate change from their special commission. The link to the report is on the bottom left. So what you're seeing right now is that we're currently in a scenario of about 1.5 degrees of warming. And that's where you see the chart on the left. So 1 to 1.5. We're currently at 1.5. And where the gray bar goes across is the 2006 to 2015 level of warming. We are at risk of increasing risks to all kinds of different systems because of global warming. And when you go to this link, you can actually look up all of the RFC numbers that I've listed here and see what it means. But it's basically RFC 1 is basically threats to Arctic environments and the Great Barrier Reef. All these unique environments are destabilizing, and the risk is getting higher and higher of them actually, of all the Great Barrier Reef going dead, and the Arctic environments destabilizing, and the Thwaites Glacier suddenly melting and then sliding into the ocean. So that's just one of those bars on the left. And you've probably seen in the news RFC2, the extreme weather events that are happening with the huge amount of flooding in Pakistan, in Europe this year. I could go on and on. All you have to do is open in the news and you can see RFC2 and what's happening there. And it's just going to get worse. So I'll let you go further down this rabbit hole, and on your own, you can look up the RFC3, RFC4, and RFC5. I really do encourage you to do that if you're not familiar with it already. So the current policies actually put us on track for 3 degrees of warming by 2100. And there's a wide uncertainty range. So it could be not so bad. We could just stay at about where we are, or slightly above where we are at 1.9, but it could go as high as 4.4 degrees of warming, or even higher. So this chart is also in the IPCC report, and there's a really good blog post on the breakthrough.org about the 3 degrees Celsius world, and I encourage you to read about that. And we all know that extreme weather is on the rise. It's not only damaging to our built environment and our ecosystems, but it tends to happen in areas where people have less ability to, less economic ability to be able to bounce back from it. So what roles do our buildings play? We already saw the overall impact of 39% of the global emissions that are attributable to buildings. But how are typical buildings performing? What can we do to reduce the climate impact of our existing and new buildings? And what should you do and keep in mind when doing so? I have some good news and some bad news. The average building does not perform well. It's actually pretty pathetic. So buildings are usually 90% less efficient than they could be. Could you imagine if somebody was trying to sell you a car and you had a choice between one brand and another, and you found out that the brand that you were thinking about buying was 90% less efficient than the other brand? You would be pretty annoyed at the salesperson. Well, that's the way it is with architectural design today. Buildings are usually 90% less efficient. And why? It's kind of crazy when you think about it, but bad urban planning and trendy architectural designs with all that window wall, they do not harness the free heating and cooling energy from passive design measures. And they need a lot of fossil fuels to make them comfortable. So just think about those towers of glass that are really trendy to build right now. And it might be cheap right now to build them with free carbon pollution. But in a decade or two, how cheap will they be to heat and cool? How comfortable are they right now? Most office buildings can't even have people inhabiting the space right next to a window because it's so cold and uncomfortable. And going back to the climate, just think about that path that we were on. And I'll just go back to that image. Think about that path that we are on. We have to reduce emissions so that we don't continue on track for that 3 degrees of warming by 2100. We've had many, many experts say that humanity will not survive a climate that is warming by more than 2.5 degrees. Some say even 1.5 degrees of warming. So if we think about the continuation of existing buildings to pollute into our environment, they contribute to this ever-growing gap between the current emissions track that we're on and what we need to limit the warming below the 2 degrees of Celsius. And with every year of continued emissions growth and every building that gets built that is not efficient, that could be 90% more efficient, it increases the amount of fossil fuels are used. And we need to increase the amount of clean energy in order to offset that. So it really makes that low amount of warming under the 2 degrees unlikely, and the high amount of warming likely. And I should change the wording on that slide. I will change it before I submit a final PDF for record. But yes, it's making it very unlikely that we will decrease our trajectory towards that 4 degrees of warming. So what can we do to reduce the impact of our buildings? Well, we need to look at our existing buildings and how they can be reduced so that we can meet our emission reduction targets. Plus, retrofits make financial sense. There's really good returns on investment over the long term of doing a retrofit. We can also help by evaluating buildings and real estate portfolios to create strategies to reduce the energy use and reduce their climate impact. We're experts at putting together strategies for real estate portfolios. And what it means is that you figure out a benchmark for everything, and then you tackle the energy pegs on the portfolio, and you tackle the buildings that have deferred maintenance, and you look at combining them all together. And when it comes to energy use, I want you to have this idea. I want you to have this, like, really understand that we can't just slap renewables on the roof and have the building net zero. Because the building is using 90% more energy than it actually needs to use, renewable energy systems are not going to have enough impact on that. And offsets are really iffy. We have to look at additionality with offsets. We have to look at how they are done to make sure that they are permanent. You can't just plant a tree these days and get an offset that is legitimate, because what if that tree is subject to a severe weather event? What if that tree is in an area that's going to get drier and drier and it's just going to die? So when I was looking at choosing a carpet for a facility, gosh, a couple decades ago, when I was working more on the design side of things, they told me, well, we have a whole forest and it offsets our emissions for our carpet manufacturing facility. And I said to them, and I think it was back in early 2000, I said, have you looked at the climate resiliency of your forest? Have you looked at the species within that forest and see if those are the right species that you should have? And how are they going to be? Are they going to be thriving in the 2020s? Are they going to be thriving in the 2030s and onwards? Because everybody wants to just kind of buy an offset and then be done with it. But there aren't enough offsets in the world to reduce our emissions. So how do we retrofit buildings? What do we need to keep in mind when we're doing so? It has to be economical. So where are you going to get the capital? Are there deferred maintenance issues that you should address at the same time? What type of procurement method will you use? Is it going to be more like an ESCO or an energy service contract? Or are you going to do construction management? Or is it going to be a lump sum bid? And how will you get a competitive bid for this work? The procurement process is really in its pioneering days, and we have a lot of experience working with organizations that want to do retrofits on a portfolio of buildings. We were able to help the City of Toronto's Toronto Community Housing Corporation that owns a portfolio of buildings, and we wrote their prototype RFP for the retrofit of 7 buildings on 4 different sites. And they were able to get a competitive bid for the work, and they hit a lot of energy savings for that work, and we won a Clean 50 top project award for that work in 2021. So it was really prototyping how to get competitive bids, and that work hasn't been brought into the commercial market yet, and we're just about to do so. When you're doing a retrofit, you have to be careful that you don't inadvertently create a different problem. So how can you circumvent unintended consequences that can have a huge impact on your building's longevity and safety? How will the new wall assemblies be designed? How will you address climate resiliency at the same time? There was a huge issue with leaky condos in British Columbia because the wall assemblies were not designed properly to take all of the humid environment, the humid climate, and all the rain. And they ended up not being not having very much longevity at all. And they ended up leaking, and the buildings were almost destroyed by the weather. Climate resiliency, it could be anything from what level of filtration is put into your air system of your buildings to address viral transmissions, to the amount of robustness of the structure and whether it can withstand the increasing rate of earthquakes and the increasing intensity of earthquakes that are coming. And how do you move a portfolio of buildings to net zero? It becomes really complicated. So I'm going to talk about what I discovered working on a portfolio of buildings a few years ago for Perkins & Will Architects in Colleges, Ontario. I'm going to talk about deep synergistic retrofits, and I'm going to talk about zero carbon buildings. So I was working for Colleges Ontario through Perkins & Will Architects, and we had all of the building managers put together a whole assessment process of what retrofits they had done in the past, what energy their buildings are using, and we put together a database of retrofits and their cost per ton of carbon. And then we wanted to inform the carbon market that was going on in Ontario. There's a public carbon market, and the funds that were being collected in the carbon market were being redistributed by the Ministry of Energy and Climate Change. And we had $500 million to distribute to colleges and universities in Ontario. And they were trying to decide how to distribute and how to award that money. So I led a study for them about what retrofits would have the biggest bang for the buck in terms of cost per ton of carbon. And the findings are kind of interesting, and they align to the findings that the CAGBC or the Canada Green Building Council found in their funded study called Decarbonizing Canada's Large Buildings, and the link is in the bottom left corner for you. So what they found was that the owners of all large buildings can slash their energy use by more than 70%. And that's especially office buildings. And for colleges in Ontario, it was those modern lecture hall buildings, the simple ones, right? All glass. Now, the barriers are these really long payback periods. So if you talk to an energy manager in a building, usually they don't want to talk about anything that has less than a 5-year payback. And some of these retrofits can have 25-year up to 35-year payback. Now, these can be barriers to their economic viability. So new financial instruments are needed. These need to be considered like long-term investments. And most people aren't doing that yet. The third thing that I discovered is that most buildings cannot hit net zero emissions on their own, but some can be retrofitted so that they are harnessing the passive solar and renewable energy, and it can make them carbon positive. And that always comes down to location and its access to solar, access to other renewable energy systems, and the ability to retrofit the building envelope. because some of them are more difficult than others. And then lastly, deep synergistic retrofits are best at addressing the climate impact, and I'll explain what those are. That's a phrase that I came up with a few years ago. So what is a deep synergistic retrofit? A normal deep retrofit is just reducing the heating and cooling loads for the building and then fulfilling those loads with more efficient equipment. So a normal deep retrofit can trap in deadly radon gases, volatile organic compounds, and cause the buildup of mold. It can also have those unintended consequences that I spoke about previously about the building's longevity and the climate resiliency. A deep synergistic retrofit, it keeps the occupant in mind. And this is a picture of a really nice lady that was living in the tower retrofit that I worked on for Canada Mortgage and Housing Corporation. And her big smile is because we added ventilation to her unit, and all those cooking gases and the bathroom exhausts were added. We added heat recovery to that ventilation. We designed the building envelope to deal with moisture and toxic radon gases. And we used healthy building materials in the retrofit, not just looking at energy alone. And this section is about zero carbon buildings. So if you look at new buildings, what you want to do is design a building so that it is zero carbon. And I thought it was really useful for you guys to have a definition of that. So zero carbon buildings have a significantly lower embedded carbon footprint. As you get buildings that have more operational carbon, lower operational carbon, the embodied or embedded carbon becomes a bigger portion of the overall carbon footprint. So this is becoming increasingly important. Cement and steel are two of our biggest contributors to climate change for building materials. And if we continue building with high embodied carbon materials, then we will blow past our two degrees of warming budget on building materials alone. So we do have to look at lower embedded carbon materials. Zero carbon buildings are designed to be exceptionally energy efficient. And we're going to compare some energy use intensity scores near the end of this presentation. And they use renewable energy systems that are on site to power the buildings. Is LEED the best rating system? The USGBC's LEED Green Building System has been very popular. It has reduced the carbon footprint and ecosystem impacts of millions of square feet of projects around the world. I've personally worked on probably over 40 LEED projects. But it also has blind spots. So I wanted to talk about the blind spot today in the in measuring energy savings. LEED uses a comparative energy savings according to ASHRAE 90.1. And because of this, the highest rating of LEED will not guarantee that the design will align to the climate reduction targets of 1.5 degrees Celsius of warming. And I'm bringing all of our conversations back to climate change and that amount of warming, because it's really the amount of risk there is to humanity being able to continue multiple generations from now. A second certification that I want to look at is the passive house certification. A passive house uses 90% less heating energy than an existing house. And this type of certification can be used for commercial buildings as well. It's very well tested for commercial buildings. So even compared to an average new building, more than 75% of the energy is saved with a passive house. So the heating energy consumption of a passive house is around 1.5 liters of heating oil, equivalent per square meter of living space per year. So it's many times lower than that of a low energy house. And 1.5 liters of heating oil is about, I think it's about 4 quarts in 10 square feet. So maybe that gives you an idea. It's very, very low. There is a standard for retrofits called the Passive House Retrofit Standard. It has a very ambitious energy use intensity target. Continuous insulation is used in that retrofit, like a blanket, to eliminate the heating and cooling loads. They also eliminate the thermal bridges. Thermal bridges are pathways for heat to find their way out of the building. And the heat will go in the path of the least resistance, and usually along the pathway of something metal. Passive house retrofits are designed using an airtight building layer. So there's an layer of airtightness that's put in that wrap of continuous insulation. And they also use vapor barriers as a separate layer. The components need to be certified. They need to be high performance passive house certified windows and doors. We usually put in 100% fresh air ventilation and heat recovery. And we use passive house certified heating and cooling components. The Canada Green Building Council has come out with their zero carbon building standard, and it's in version 3 at the moment. So they look at the net emissions of embodied or embedded carbon, the operational carbon from how efficient the building is operating, and then the avoided emissions. And I'm not quite in agreement with the avoided emissions because they include the purchase of green power and carbon offsets. I also thought it would be important to bring to mind about the Zero Tool EUI calculator. Back to the car that's 90% less efficient than its competitor. It was really important for architects to realize how inefficient their buildings are when it comes to climate change. So there was an organization called Architecture 2030 that was established, and they issued the 2030 challenge in 2006. And this was a request for the global architecture and building community to step up and adopt EUI targets for their buildings and commit to designing all new buildings, developments, and major renovations as carbon neutral by 2030. And we're currently at the target of 80% reduction for new buildings. And there's a Zero Tool EUI calculator that can be used as a target generator. The link is on the bottom left of the slide. So these are comparisons between an EUI target for a 20,000 square foot library in Toronto using the Retrofit EUI target for retrofitting to the Retrofit standard. It is at 30 kilowatt hours per meter square per year, or 2.64 BTU per square foot per year. And now you can compare it to the CAGBC Zero Carbon Building Design version 3 TEDI target at 32, just slightly above that. And the Zero Tool EUI target, which is a 80% reduction over 328. kilowatt hours per meter square per year. And the zero tool EUI target is 66 kilowatt hours per meter square per year. So it's really, I find with my design teams that it's even a stretch to get the design teams to use the zero tool EUI target of 66, let alone the CAGBC or the Retrofit targets. Now, the reason is that they've done the massing and the design of the building. They've gotten too far to be able to hit these first two targets. And when we get involved really, really early on in the process, it's possible to hit these Retrofit and CAGBC zero carbon building design targets. But if we leave the architects on their own, then they'll find it even nearly impossible to hit the zero tool EUI target. So just to wrap up the talk and just give you some tips if you're ever working on a project with a company, maybe an organization has a portfolio of buildings. Use a green building strategist. Doesn't have to be me, but find somebody that's qualified. They should be a certified passive house designer, because if you know that extreme level of performance, it's such a high level of performance. It's an amazing system. If they know all of those tools and green building strategies, then it's easy to do everything else. It's easy to get achieve lower targets. So always use a certified passive house designer on your projects. Do a portfolio analysis, like find those energy pegs and plan retrofits and look at alternative financing measures for those retrofits. Do a deep synergistic retrofit feasibility study. Find out, what the potential is. I looked at a century-old warehouse building, and the potential was 80% savings and a 30-year payback. And they're currently vying for both a deep retrofit competition that the City of Toronto is holding right now, and also some grants. So you don't know what is possible until you do that feasibility study and that deep analysis. And then when you do decide to hire a design team to do that retrofit, set an EUI target that's really ambitious. Be careful about hiring your design team. Bring them together in either an in-person or an online eco-charrette, where everybody can talk about the different ideas, the different energy conservation measures, the different bundles that you're exploring. Do early stage energy modeling so that you can discover what the opportunities are, where those sweet spots are for your insulation levels. And do follow through in your design process and do thermal bridging assessment. That can be 10% of the energy right there. And most people skip that step because it's a little bit expensive, but it's so worth it. That's me. If you want to talk more, I'm always open to coffee chats. So there should be a link on the website to hit me up.